So hello guys, Ram Ram. All the energy in us comes from God only. Okay, so always remember God and then start all your tasks. Okay, so hopefully you're enjoying your weekend, guys. This problem which we are going to solve today is the weekly contest 433 question. Okay, it's based on dynamic programming, guys. Very high level dynamic programming is used here. Okay, which is actually three dimensional dynamic programming. So, if you are a beginner in dynamic programming, I will suggest you to first complete this my premium prerequisites for the DP course. Okay, so please read my written tutorials. I have the best written tutorials on dynamic programming, and then please watch some of my DP videos. Once you are done with these things, then you can solve this question. Before that, don't attempt this question. This is for the people who are, beginner in DP. Now, if you already know DP, then let's go ahead. So, this question is saying that you are given three arrays, and on each day you have to select one element from each of the three arrays, and two conditions should be satisfied. So, this makes the question very hard. Let's solve the easy version. Easy version we will only try to satisfy the first condition, which is no two adjacent types should match. Okay, the nice thing is that this easy version, guys, this if you only consider this much question, na this much, you ignore the second condition. If you only consider this blue part, na, this blue part is already solved and asked years ago on AtCoder. You can see that you are given three arrays. From at each index I, you have to select one element from either of the three arrays such that no adjacent element should match. This is a standard DP problem. But still, let's revise what they are trying to say. So let's say you are given some numbers. This is your first array, this is your second array, this is your third array. Okay. 3, 5, 8. Okay. Then 1, 8, 2, and something like that. There are many numbers here. Okay. You have to, at each index I, you have to select a number, guys, so that the final sum is minimum. Final sum should be minimum, as small as possible. Okay, so generally you people will say that, sir, at index I equal to 1, I will select element this one 3, and at index 2 I will select this one. Now, why did you do that? Because this is row number 1, this is row number 2. From row 1, there were 3 options. But you selected 3 because 3 is the smallest one. In row number 2, again, there are 3 options. But 1 is the smallest one, you selected 1. But it is still not allowed. You will say that, sir, for the first 2 rows, the answer is 3 plus 1, 4. Which is wrong. Why it is wrong? It is wrong because you cannot repeat the type of elements. In row number 1, you selected a type element. You can see you selected this guy, which is a type element. But row number 2, you cannot again select a type element. You can only select b type or c type. The type should not repeat, guys. I hope you now got it, that each row adjacent type should be different. Okay, so for the second row, you can either choose the B type or C type. So which one will you choose, 8 or 2? Obviously, you will choose 2, right? Because in 8 and 2, 2 is minimum, which is C type. So row 1, I choose A type. Row 2, I choose C type. So A type here, cost is 3. Here in row 2, C type. C type means from the C array. You consider this as A array, this as B array, this as C array. At each index I, you have to select element from at index I from one of these arrays. You can only select one array at a time. But also, for each row, the array you are selecting should be different. Here it was A type, here it is C type. So 3 plus 2, 5. 5 is the minimum answer if you are traveling only from index 1 till index 2. In question, we have to travel from index 1 till index n. So how can we solve this by DP? Very easy, very easy. In this question, what will be, let's think about what will be dp1 of a. Dp1 of a should be nothing but best way, best way to travel, best way to travel from index 1 to index 1, best way to travel from index 1 to index 1 such that a type element is selected. So guys, you have to travel from index 1 to index 1 only, and you have to select at index 1 a type element. So dp1a is nothing but 3. Okay, dp1a is 3. What will be dp1b, guys? dp1b means best way to travel the first index such that b type element is selected. So dp1b will be 5. What will be dp1c? Best way to travel, one means in best way to travel first index. If you at index 1 you are selecting element c, so dp1c is 8. So these things you have calculated. Great job, great job. Now guys, think about what will is the meaning of dp2 of a. dp2 of a means you travel till index 2. You travel till index 2. What is the best way to travel till index 2? Such that at index 2 you are selecting a type element. So at index 2 I am selecting this a type element. So at index 2 I am selecting a type element. So dp2 is nothing but a2, which is actually 1, plus, guys, if at index 2 I am selecting a type, then what can I select from index 1? I can select either uh, B type or C type, right? Because the type should not match, right? If you are selecting A type in this row, then the previous row should have different type. So either B type or C type. So minimum of B type and C type you will take for row 1, right? So minimum of B1 comma C1. So guys, what is the formula for DP2A? DP2A means at index 2, you selected the guy which is of this current row A, A2, and for the previous row you can select minimum of the elements of different types which are B and C. Okay, but guys, I can rewrite this as what is B of 1? B of 1 is nothing but, do you remember from the past, it is nothing but dp1b. Dp1b, basically the best way to go till index 1 selecting B is nothing but B of 1. And what is C of 1? It is dp1c, which is the best way to travel till index 1 such that C element is selected. So like this, guys, you can calculate dp2a, dp2b, dp2c. Let's calculate dp2b also. It's easy, it's easy. dp2b means best way to reach till index 2. This is index 1, this is index 2. Guys, what is the best way to reach index 2 such that at index 2 you are selecting a guy of type B. So it will be this guy is 8 na, B2, this guy is B2, this guy was B1, this is 8 is B2, which is 8, plus what will you, if you are selecting 8 here, what can you select in the previous row? In the previous row you can select either A type or C type. So it is minimum of A1 comma C1. You can rewrite this as minimum of dp1c, dp1a, whatever is the minimum from those, that different type I will add to the b2. So guys, similarly, I hopefully you can make the formula for dp2c also. So guys, now you can generalize this formula for any index I. Let's say this is our n, okay. For any index I want dp ib. What is the meaning of dpib, guys? dpib means best way to travel from index 1 to index I, such that in the ith row b element is selected. So dpib will be bi plus minimum of, what can you select in the previous row, guys? What can you select at the ith minus 1 row? Either you can select this guy of the A type or the C type. So minimum of dp I minus 1a, dp I minus 1c. So guys, I hope you understand the meaning of this. dp I minus 1a means what? Best way to travel from 1 to I minus 1, such that at I minus 1 position this guy was selected. Because here this guy was selected and in this row this different guy is selected, so it's correct. So one way can be this, and dpi minus 1c means best way to travel from 1 to I minus 1, such that at I minus 1 this guy is selected. So at I minus 1 you are selecting C, and at I you are selecting B. So that is also valid. There are two options. So minimum of both of them. So guys, by doing this now you can calculate all DPI values from 1 to n. In O of n into 3 time you can calculate, you can run a for loop from I equal to 1 till n, and you can write the formula of dpik in one line here, dpib in one line here, dpic in one line here, and the job will be done. Okay, so guys, when you reach at the nth index, what will happen? When I is equal to n, here you will know the best way to travel from 1 to n, such that in the nth row you are selecting either a element if it is dpna, or the best way to travel from 1 to n if at the nth row you are selecting b type element, and dp and c means best way to travel from 1 to n if at the nth position you are selecting c type element. So guys, maximum of these three values will be the final answer, because best way can either end at nth row in type a or type b or type c, right? So in n into 3 total operations, the problem is solved in n into 3 time complexity. So congratulations, you understood that. You can see guys, same things have been written here. Same things which I explained you have been written here. You can just run a loop and get the things done. Okay. Now let's get to the harder version. So what we solved till now, whatever we solved till now, is the same question LeetCode asked us. But guys, now see, one condition we have satisfied. We are always making sure that no two adjacent rows are matching. No two adjacent rows are matching. No two adjacent rows are matching. Okay. No two adjacent rows are matching. Okay. But guys, now one more condition is there. Equidistant rows should also not match, and n is even, by the way. Equidistant rows should also not match. Equidistant row type should also not match. So now guys, things get interesting. So guys, what they're trying to say now is that Ram Ram. So now guys, they are saying that I am using the name ABC, guys. In the question, they have not written ABC. They have just declared this as 0, 1, 2, and this going from 0 to n minus 1. But for easy purpose, I am saying that this is A column, B column, C column, and I am considering row 1, row 2. I hopefully you can change it according to the question needs in your code. Okay. So let's say this is okay. Let's say we are having something till row 5 only. Okay. So this is our n. Okay. So they are saying that obviously the row 1 type should not match row 2 type. This we have achieved in the past, and row 2 type should not match row 3 type. These things though should be eligible everywhere. Okay, row 4 type should not match row 5 type. Okay, this is the condition 1. This we have already achieved here. No two adjacent rows should have same type. Okay, but now the problem comes with let's say this is our last row n. Okay, now they are saying that one more condition: row 1 should not match row last row. This row should not match this row, just like palindrome. You know now, in palindrome these things are equal actually. Row 2 should not match row n minus 1. So second row should not match second last row, and third row should not match this row. So hopefully you understood that apart from adjacent rows not matching now, the first row should not match the last row type, row should not match the second last row type, third row should not match the third last row type, and n is even, so you always have that values with you. Okay. Okay G. So guys, we have to take care of two condition. One condition though we know how to take care of. We are lovely people. We know that the easy version to already wait huh? Easy version condition plus row type or element type of first row should not match last row, element type of second row should not match second last row, and so on. Equidistant row type should also not match. So now guys, what is the solution? If you do a little bit of brainstorming, you will come to know that three-dimensional DP solves the question. DP1AB, ABC, BC. So guys, what is the meaning of DP1 BC? DP1 BC means that from the first row you selected B type element. So from the first row I selected B type element, and from the last row I am fixing the first row and the last row by writing DP1B. And from the last row I selected C type element. So guys, what will be the answer for DP1BC? From the first row I selected B type, B1, plus from the last row I selected C type element. So this is C of n. Now guys, why is doing this helping us? You know, why do we increase the states of DP? Why did I add one more dimension? Necessity is the mother of invention. You cannot solve this question just by using the earlier states. No, you need to do one more. Why? Because when you introduce one more state now, you can keep track which element you selected at which place. Because now whenever you select something here na, it directly affects the things which are here also. Okay, so DP1BC means what element are you selecting at row 1 and what element you are selecting at row n. This B means what element you are selecting at row 1, B1, And this C means what you are selecting in the end. Cn. So guys, what will be dpab? dp1ab? dp1ab. This basically means that the best answer to the question, if at row 1 I am selecting this element and the last row I am selecting this element, okay? What will be dp1cb? dp1cb means in first row I am selecting C element and in last row I am selecting B element, which will be C1 plus Bn. So like this guys, I can exactly keep track what I am selecting at where. Now guys, there is one special case you need to handle. DP1BB. Now many of you will say, sir, this is such a easy case. In the first row I am selecting B type, B1, and in the last row also I am selecting B type. So sir, answer is B1 plus Bn. Wrong. Selecting same type is not allowed. Not allowed. So you will write here as not defined. Whenever both the types are same, you will write not defined. Because selecting the same type in first row and last row is not allowed, beta. So you write non-defined or you write infinity. Because we want the minimum answer, na infinity can never be minimum. Okay. So hopefully you know how to calculate DP1 all the values. So guys, you can see that at this place there can be A, B, C. At this place also there can be A, B, C. So you will have to calculate here. There will be three possible numbers coming up, either A or B or C. Here also three possible numbers coming up, A, B, C. So total 3 into 3, 9. So it will take 9 iterations. Like you can write two for loop. One loop will go from 1 to 3, where 1 means A, 2 means B, C means 3. And another for loop J going from 1 to 3 to calculate all the DP1IJ values. Okay. If they both are different, then the answer is simple. Whatever is the type here, that type first row and this type last row. But if they are same, then declare it as infinity, guys. So lovely people have understood how to calculate DP1. Okay. But guys, what about DP of 2? DP2BC means what? DP2BC means at second row I am selecting B, and what is the equidistant row with second n minus 1? At n minus 1 I am selecting C. Obviously if they are same, if you write here also B, again the answer will be infinity. Okay, so for same I am not even thinking. What is the DP2BC means? At second row I am selecting this guy, and at n minus 1 row I am selecting this guy, which is B2 plus C of n minus 1. But you have fixed what to select here, and you have fixed what to select here. But for DP2BC you need to know this also, na, what you selected at 1 and n. So there are many options to select. So one third value will be added. So answer is third value. So DP2BC is nothing but, guys, what element you selected at the second row, what type you selected at second row, what type you selected at the congruent row, which is n minus 1 row, plus the third value. What is the meaning of third value? Third value is nothing but the minimum possible answer for filling up first row and n minus 1 row. We are clear with 2 to n minus 1. We know that at 2 we are selecting B, and at n minus 1 selecting C. So you wrote B2 plus C n minus 1. But to reach 2 and n minus 1 state, you need to first solve 1 and n state, right? So there are 9 options which you can select from 1 and n. So third value will be minimum of all the 9 option, guys. What will be the third value? minimum of all the 9 options. So I'm writing here also. See, you understand na, select type A guy from row 1 and type B guy from row n. Minimum answer to do it. What is the meaning of and here also let me write here dp1 bc. Select type B guy from row 1 and type C guy. This is a nice dynamic programming question. dp2 bc is nothing but select type B from row 2 and this from row n minus 1. Plus best answer possible for row 1 to n, which is nothing but 9 possibilities. 9 possibilities. Which are the 9 possibilities? You will take minimum of all of them, which is dp1 aa, dp1 bb, and there are many dp1 ab bc cb vc, right? So guys, hopefully you understood the brilliancy that dp2 bc means. At second row I'm selecting this, at n minus 1 row I'm selecting this, plus third value should tell you the best way to fix one and nth row. But for deciding what to pick at one and n row, there are 9 possibilities. Okay, one is dp1 aa, which is already not allowed because both of them are same, it will be infinity. Another is dp1 ab, another is dp1 ac. So these 3 values. Then dp1 ba, bb is not allowed, bc. Then dpc ca, cb, cc again not allowed. So these 9 values. But one more thing you need to check when you are checking these values na. Let's say from this row na, you are selecting some I1 index for first row, and for the last row you are selecting J1, okay, type. So I1 should never match I1 should never match B and J1 should never match C. Then all the conditions are satisfied. Problem solved. So here all 9 possibilities are nothing but what? Minimum of dp1 of I1 J1, where I1 should never be equal to J1. Basically, at what is happening at second row and n minus 1 row, with that we already know. Now we need to decide all the possibilities of first row and nth row. So if first row nth row all will be of the type dp1 I1 J1. But while taking minimum, make sure that I1 is not matching J1, and also I1 should not match B. I1 should not match B, guys. Whatever type you are selecting here should not match the type I have selected B type at second position, right? So I cannot select I1 as B. I1 can either be C or it can be A, because adjacent also not allowed to be equal, na ji? Yeah. So I1, make sure in the for loop you check that I1 not equal to B and J1 not equal to C. So done, guys. dpijk means select type J guy from row I and type K guy from row n minus I plus 1. Minimum answer to do it. Final answer will be what? Final answer will be dp minimum of all possible values of dp n by 2 I1 J1, such that I1 is not equal to J1, because yeah, that's it. Because you cannot pick the same types na for n by 2 and n by 2 plus 1 row. So we only have to travel half of this array, okay? Because when you are at dp2, it means you have selected what? You have selected 2 and n minus 1, and you know the best answer for 1 and n also. All this is included in dp2. So let's say this is dpn by 2. So in dpn by 2, what will be included? Obviously, the best answer of 1 to n will be there already. Best answer for 2 to n will be there already. And 1 to n will be there. 2 to n will be there. All other values. And the last will be n by 2. The middle of the even size palindrome. N by 2 plus 1. N by 2 and this consequent value n by 2 plus 1. So these all will be there. So all these values can be immediately calculated. Why? For any index I, na guys, it's very easy. For any index I, na, any index dpibc will be nothing but what? It will be bi plus at the congruent position whose value will be n minus I plus 1. You can see for 1 it is n, for 2 it is n minus 1, for I it will be n minus I plus 1. So c of n minus I plus 1 plus the third value. Third value will be nothing but best answer, minimum best answer for dpi minus 1. When you are calculating dp2, so the minimum best answer for dp1. When you are calculating for dpi, the minimum best answer for dpi minus 1, because dpi minus 1 already stores the answer for 1 to I minus 1. Okay, and everything from n minus I plus 2 till end. So if you know this and this, then I and this is also solved, then whole thing is solved. Okay. So obviously there will be many types there, so you will check all the types. So can check the C++ code. The implementation is just for loop. So Java Python you can write on your own or ask ChatGPT, but Java Python codes will also be uploaded soon. So like in the contest I went there, got a great rank and solved this problem also. So this thing guys, you can see first you fill up the, instead of 1 I've used a 0 here, so you can see you can fill it up. Then from row 1 till row n, again you check the ij condition, fill it up, problem solved, submit, it will work. Okay, so with the name of God, Ram Ram, hopefully you guys enjoyed this session and you got a lot to learn from it. All the best.